Hi everyone, my name is Prachi Shevgaonkar. I'm the founder of Cool the Globe, a citizen-led app for climate action. I welcome all of you to Net Zero. Have you ever wondered how technology and sustainability intersect to combat climate change? Our Net Zero guest today is a leading expert in this field. Professor Srinivasan Keshav is a renowned computer scientist and environmental advocate, currently serving as the Robert Sansom Professor of Computer Science at the University of Cambridge. His work sits at the intersection of computer science and sustainability, making complex concepts accessible. Dr. Keshav's passion for sustainability shines through in his pioneering work on the permanent additional carbon tonne PACT method, which revolutionizes the way we value carbon credits for forest conservation. Welcome to Net Zero, Professor Keshav. It's an honor to have you here. Can you explain in simple terms how the permanent additional carbon tonne method works and how it helps us value projects that protect forests and combat climate change?
So the P for PACT stands for permanence. How do we value the permanence? And A stands for additionality. And so this additionality is done using this matching, this kind of approach which is widely used. The P stands for the approach of valuing impermanent sequestration. PACT then allows us to say for a particular avoided deforestation project, what is the total number of permanent additional tons that are coming from it rather than the tons that they claim they have. So it gives us some certainty, and this allows us to compare projects from different parts of the world.
In very simple terms, why are tropical forests important to avoid the worst effects of climate change? Why is it so important to stop the rate of deforestation?
We can think of the Amazon forest as creating the rainfall by essentially transpiring. The water comes from the ground into the air, and then that forms clouds and then creates rainfall. So it's the cycle of rain and water that the forests create. And of course, they provide livelihood, as I already mentioned, the livelihoods for many people.
So while we can quantify the avoided emissions, it's difficult in the carbon credit market to get people to give preference to individual actions and give sort of reliability to individual actions. Do you think some of the similar principles as PACT could be utilized, incentivizing and rewarding individual climate actions?
The general principles we have is leakage. Leakage means that you didn't cut down the forest here, you cut it down somewhere else. So you leaked somewhere. So these ideas of permanence, additionality, and leakage are very broad. So let's take example of somebody who decides that they did not take a car to work today, they took the bus. Right? So they didn't drive, they took the public transport, they took a bus or a train. And do we say, should we give them credits or not? We find this person and some other person who are matched in multiple respects. We look at what are the drivers of the action. What are the drivers? Distance to the workplace, socioeconomic status, etc. We match them and we find the pattern strengths. In this case, permanence is sort of guaranteed. That's nice. And then leakage says, okay, you didn't use car, use public transit.
Is there, even after that, is there willingness in the market to invest in these kind of things, maybe like a technological carbon capture and storage solution? Are people willing to invest in these kind of solutions?
I have to say that technological solutions are, in some sense, the better ones. Right? There's no question about it. You're withdrawing carbon from the atmosphere, putting it into, let's say, a calcium carbonate, chalk deposit. It's permanent. We know it's permanent. The problem is the cost. So if the costs come down, of course, that's good. We also have the additional side benefit, a co-benefit of biodiversity protection. It's not like either or, it's both of the above. Technological solutions, good. Let's do that. Let's try to bring the cost down. Let's try to scale it up. That's also a very good thing, right? What we are trying to do from our side, try to bring back trust into the market by saying, okay, yes, there were problems, but here's new science, new approaches, new techniques which we can use. And so we're working in collaboration with the scientists and other universities. And also we're working with something called the Integrity Council for Voluntary Carbon Market, ICVCM. The ICVCM has taken upon itself the task of bringing integrity for the voluntary carbon market.
So how can we use technology and computer science to build trust in the carbon credit ecosystem?
The trust is both ways, right? In one direction, the purchasers of credits, they do not necessarily trust that these actions are being taken, that things are actually being done the way they're supposed to be done. And on the other side, we don't know the people who are buying these credits are actually legitimate users of credits. Credits should be used only after all other possible actions have been taken to reduce carbon footprint. With computer science, we have a few very powerful techniques that we can be used. We are able to look at large data sets and analyze them. Hundreds of terabytes of data is available. So doing that at scale requires big computer systems and a lot of analysis. So we've been working for the last few years on trying to create this engine, as we call it, which takes these data inputs and then does computations on them. Most importantly, the computations are being tracked. So when we do a computation, we say this data came from this source, this data came from that source, and we use what are called hashes, which are essentially fingerprints that say, this is the version of the data we use, this is where it came from, this is the hash. So if anything changes, the hash will change, and we know that something is wrong, right? So that's the first thing. That is, we have essentially computation with provenance. We know where the data is coming from, we have hashes. The second thing we're doing is that we are making all of our work transparent. So the methodology we use is published. You can go to our website, you can read the methodology, and then we're releasing the source code. We will be releasing the source code, the documentation, and all the data that we're using. It's not our data, right? It's public data. Run it yourself, see for yourself.
In all the work you've done in the fight against climate change, what gives you the biggest reason for hope?
That kind of positive feedback in terms of solar, in terms of electric vehicles, in terms of storage, and then adoption of computing has also been similarly positive feedback. Cheaper chips means more adoption of computing. So that kind of adoption means we can now start doing other things very fast. Hope for me is that people in your generation can take that lead and do things that people my age screwed upon.
How can young people like me be more involved in the kind of work you do in using technology and computer science to fight climate change?
First of all, start with education. Being skilled and putting the effort into learning is very important. Learning is not easy. So when you're young, you have 10,000 hours, spend it wisely on learning something that you care about, that you really will benefit from. To be advocates, as you are doing, to advocate for what you think is right. Creating support organizations, such as where you feel you're not alone, that you're doing something together, I think is important. And of course, making sustainable choices. Fly less, eat less meat, don't buy things that are contributing to deforestation. Then, of course, doing something positive, planting trees, taking care of a patch of land, So these kinds of things. So learning, advocacy, joining organization, making sustainable choices, and doing your own efforts for restoration. I think these are all great ideas.
Professor, I want to thank you very much for sharing your time and perspectives with us today. They are truly enlightening. This was such a fascinating conversation.
Thank you. Bye-bye.
My name is Prachi Shevgaonkar. I add my voice to the voices of my Net Zero International youth peers to monitor the action of our world's leaders to achieve their net zero commitments. Together, we can achieve net zero.